Good morning, everyone. This is Vinay Shetty. Thank you all for coming into my dissertation project, Scenario Development in VR Engage app for accelerated learning. So, before we start our scenario, I would like to give you a moment to look over the Martian surface in the Engage app. So, right now we are on the Martian surface in an astronomical suit. The surface below our feet is the Martian surface, and you can see the craters over there. Those are the Martian craters, which looks like mountains on Earth. And this one is the Perseverance rover. This rover is the Curiosity rover. This is our lecture hall in Mars. Quite interesting. The students who can attend me for a live session can have a seat. The students who are watching me on a recorded lecture, you are free to follow me during the entire lecture. Can you explore the Martian surface before we start? You can go on the craters. You can see the Martian surface. I'll give you a minute. Yep. This is how the Engage app is designed for the Martian surface. Let's start the scenario. So my dissertation project is titled Scenario Development in VR Engage app for accelerated learning. The scenario I have chose is the space exploration on Mars through virtual reality. The project purpose of my dissertation is the objective of the study is to assess the awareness, preferences, and attitudes of the students regarding the use of virtual reality technology for accelerated learning using the scenario development in context of space research, specifically focusing on the exploration of Mars. This research aims to understand students' familiarity with VR in this context, their past engagement with VR-based learning experiences, their perceptions of VR effectiveness for learning about Martian space exploration, their preferences for VR features, potential challenges in its implementation, their preferred learning methods, and insights into the career paths that could benefit from VR-based accelerated learning in the field of Mars exploration. Additionally, the study seeks to evaluate students' overall effectiveness ratings of a VR scenario development in the VR Engage app centered around the Perseverance rover, which is this one, and the Curiosity rover, which is this one. The research will provide valuable insights into the readiness of the students for VR-based education tools in the fields of space exploration and contribute to the development of more effective and engaging educational content. The process of achieving my research objective. The research project, Scenario Development in VR Engage app for accelerated learning, presents a methodology for leveraging virtual reality technology in education. It initiates with a literature review of VR's potential in education, culminating in the identification of scenarios that can enhance the learning experience. After exploring VR options and the various options, including topics like fire escape plans in an airplane and commercial fishing in an ocean, the project strategically pivots towards the space research, particularly Mars exploration, aligning with the global significance to the research objective. The scenario conceptualization followed by scenario development has been performed and tested with students participation, iterative refinement, and comprehensive outcome analysis, including structured interviews, rounded out this research journey. Ultimately, this project seeks to assess VR's role in accelerated learning and its relevance in Mars exploration, contributing significantly to educational technological advancements. The research approach successfully ties into the stated goal of evaluating students' knowledge, preferences, and attitudes towards VR technology for quick learning in the context of space research, particularly Mars exploration. It includes extensive procedures like scenario building, student testing, iterative refining, outcome analysis, and structured interviews, all of which are intended to determine how prepared the students are for the VR educational tools and how well they work to improve the learning. Even if you have made great strides towards your research goal, the evaluation of my success will ultimately depend on the analysis of the data that was gathered and conclusions recommendations that yields for the development of instructional technology related to the Mars exploration. Now, this was the background for my research. Now coming on to the scenario, the first part which we are going to discuss is about the Martian surface, which you can see all around. The surface of the Mars is captivating and enigmatic landscape that has long piqued the curiosity of the scientists and space enthusiasts. Characterized by its reddish hue, the Martian terrain is stark and rugged expanse marked by a diverse array of features, from vast windswept equatorial plains to the towering shield volcano Olympus Mons, the largest volcano in the solar system, and intricate networks of ancient river channels. Mars presents a geological tapestry that speaks to its complex history. Because volcanoes in the scenario, but they are there in the actual Martians on the actual Martian surface. With the aid of cutting-edge technology such as rovers and orbiters, scientists have uncovered evidence of water in the planet's past, suggesting the possibility of ancient Martian life. Moreover, the surface bears the scars of meteorites impacts, revealing insights into the planet's evolution over billions of years as we continue to explore and study Mars. This intriguing world offers a tantalizing glimpse into the mysteries of our neighboring planet and its potential significance in the research of the extraterrestrial life. Now, coming on to the Perseverance rover. This is the Perseverance rover. The Perseverance rover, a remarkable feat of engineering and science, is a key component of NASA's Mars 2020 mission. It touched down on the Martian surface in February 2021 and has since become a symbol of human perseverance and exploration. Perseverance is no ordinary rover. It is equipped with a suite of advanced instruments designed to search for signs of past microbial life, collecting rock and soil samples for future return to Earth, and test technologies for future human missions on to Mars. One of its standout features is the Ingenuity helicopter, which made history as its first powered flight on another planet, demonstrating the feasibility of aerial exploration on Mars. As it roams to the Jezero crater, once a lake billions of years ago, Perseverance has already made groundbreaking discoveries offering valuable insights into the red planet's geology and past habitability. With its mission of perseverance and discovery, this rover represents a significant milestone in our quest to unravel the mysteries of Mars and advance our understanding of the potential for life beyond the Earth. Now coming on to the Curiosity rover. This is the Curiosity rover. You can actually see the rover doing the experiments as well. So that's the rover doing some experiments. The Curiosity rover of space exploration that has been an enduring symbol of science curiosity and discoveries on Mars since its arrival in August 2012. Part of NASA's Mars Science Laboratory mission, Curiosity was designed for ambitious task of exploring the planet's Gale crater and Mount Sharp, a towering peak within it, to uncover clues about the red planet's past habitability and geologic history. This car-sized rover is equipped with an array of sophisticated instruments including cameras, spectrometers, and a drill, which allows it to study the Martian terrain, analyze rock and soil samples, and search for signs of past microbial life. Over the years, Curiosity has made a series of remarkable discoveries, such as evidence of ancient lakes, organic molecules, and even seasonal variations in the methane levels, which have profound implications for our understanding of Mars' potential to support the life itself. As it continues to explore and send back the valuable data, Curiosity stands out as a testament to humanity's insatiable thirst for knowledge and our unwavering commitment to unraveling the mysteries of the Red Planet. Now, coming to the differences between both the rovers, the Perseverance rover and the Curiosity rover, both are remarkable on Mars. They share common missions of unraveling the mysteries of the Red Planet and searching for signs of past life. However, they also have notable differences in their objectives and capabilities. Perseverance, as a part of NASA's March 2020 mission, boasts advanced instruments designed specifically for astrobiological research, including the ability to collect rock and soil samples for future return to Earth. It also introduced the groundbreaking Ingenuity helicopter, demonstrating the potential for aerial exploration on Mars. In contrast, the Curiosity rover, as a part of Mars Science Laboratory mission, has focused on the studying the geological history of the Gale crater and Mount Sharp, providing insights to Mars' ancient environment. While both rovers have significantly expanded their understanding of the Red Planet. Perseverance's primary goal is to search for signs of ancient microbial life and prepare for future human missions, whereas Curiosity has contributed to our knowledge of Martian geology and environment. Together, these rovers represent the ongoing evolution of Mars exploration, each with its unique contributions to the quest for understanding our neighboring planet. Now, coming on to the last part of our scenario, future colonization on Mars. The prospect of human colonization on Mars represents a tantalizing frontier for the future of space exploration. While significant challenges lie ahead, advances in technology and growing international interest have made this vision more feasible than ever. The establishment of sustainable habitats and life support systems will be paramount, as Mars lacks the breathable atmosphere and readily available innovations in spacecraft and propulsion systems will be essential for transporting humans to and from the Mars effectively and safely. Moreover, addressing the physical and psychological challenges of the long duration space travel, which will be crucial. Collaboration between the space agencies, private companies, and international partners will likely play a pivotal role in achieving this ambitious goal. While human colonization on Mars not only presents an opportunity to expand understanding of the cosmos, but also ensure the survival of our species beyond Earth, making it a compelling and exciting prospect for the future of space exploration. So this was my scenario. Now, coming on to the learning outcomes of the scenario is the scenario of integrating virtual reality technology into space research and Martian exploration offers a multi-phased learning experience for students in their education journey. Through this scenario and subsequent analysis by interviewing 10 students, user can develop a deep understanding of VR's potential for accelerated learning, particularly in the context of Mars exploration. They learn that VR can provide immersive simulations of Martian environments, interactive elements. As you can see, the rover performing the experiments under the Martian conditions, collaborating between the students for problem solving in a virtual Mars setting, virtual tours of Mars landscapes, and visualizations of complex geological and atmospheric phenomena on Mars. This exposure broadens their knowledge of the possibilities inherited in the VR based education. Additionally, the students gain insights into the potential challenges of VR learning, including considerations related to hardware and technological requirements, educational integration and training, the content quality and accuracy, and the user engagement and comfort. This awareness equips them with a crucial perspective on the implementation of VR in educational settings. Furthermore, students learn about the diverse career paths associated with Mars space exploration, from space missions engineers to planetary geologists and science communicators. This knowledge encourages them to consider various educational and vocational avenues within the field. Overall, the scenario and analysis foster a comprehensive understanding of the benefits and complexities of VR-based education, while also nourishing an appreciation for the multi-phased nature of the space exploration on Mars. Thank you so much for attending my scenario. Thank you all. Goodbye.